We're going to apply the divergence theorem again, meaning that we'll be turning this surface integral into this volume integral. And I usually use E for this. It doesn't really matter. So like any vector calculus problem, you go and you grab your ingredients. The ingredient for this mainly is the divergence of F. So let's find that. The divergence of F is going to be partial P partial X plus partial Q partial Y plus partial R partial Z. Partial P partial X is 2xy. Partial Q partial Y is 2xy. And just like in the previous problem we did so far, they're like terms. They're not going to cancel this time though. And then partial R, partial Z, is going to be 2xy once more. So this is 6xy. Now we need to write a description of these in terms of boundaries on x, y, and z. Now check this out. This z can be solved to be 2 minus x minus 2y. And what that means is that E can be drawn like this. Our usual x, y, and z axes. This will have an intercept at 2, and then it will decrease as x increases and decrease as y increases. It'll have a y-intercept of 1, because look what happens if x is 0. 2 minus 2y, that means that z will be 0 when y is 1. Likewise, if y is 0, then 2 minus x will hit the x-axis when x is 2. So this will have a y-intercept of 1 and an x-intercept of 2. That means that this is the shape of the plane that we're looking at. I know that this uses the word tetrahedron, but the tetrahedron is formed primarily by the plane at the top, the tilted one. It also is formed by these planes, x equals 0, y equals 0, z equals 0, but those just form the walls at the back and on the bottom. The complicated thing that you need to worry about is the tilted surface of the tetrahedron, and that's what we got just now. So in the interest of writing bounds of integration, z will go from 0 up until 2 minus x minus 2y. Back when we did volume integrals and we first had to flatten and then flatten again, we had the experience of writing these regions in 3 dimensions, then flattening them down into 2 dimensions. And this is why it's so handy to have the intercepts as I labeled them up here. Because if you have those intercepts, it makes it so much easier to write the 2-dimensional version of the function. It goes from a y-intercept of 1 down to an x-intercept of 2. And here I'm translating this to down here. It's exactly the same picture, just drawn from a different perspective. So here I can see that y goes from 0 up until this line. And what is that line? It is a slope. Well, it has an intercept of 1, and its slope is -1/2. You can see that because rise over run. It has a rise of -1 associated with a run of 2. So this will be 1 minus x over 2. Now that the z and the y have both been flattened, x is a simple interval of numbers, and x will go from 0 up until 2. Here I'm looking at this interval right here. So what I'm doing is integrating this function. So then the surface integral, which in principle is equal to the integral over the three-dimensional region of the divergence, blah, blah, blah. This is always true, but what this ends up being equal to in this particular case is x from 0 to 2, y from 0 to 1 minus x over 2, and z from 0 up to 2 minus x minus 2y. The integrand is 6xy, and we're going along z first, then along y, and then along x. So now we're going to do the classic thing where we split it into the inner, the middle, and the outer. Everything is polynomials, so the worst thing we're going to have to do is like do some maybe messy expansions, but it's not conceptually difficult. The inner is going to be 6xyz, because we are integrating with respect to z first. And this will be at z equals 0, and z equals 2 minus x minus 2y. So that's the correct equation as verified by up here, 2 minus x minus 2y. And so we've got 6xy multiplied by 2 minus x minus 2y. And then we ordinarily would write, 6xy times the lower bound, but that's 0. So we don't really need to do that. Let's expand this to make the future integrations easier. It'll be 12xy, that's that part, minus 6x squared y, that's that part, and then minus 12xy squared, that's that part. Now for the middle, we're integrating here along y. So term for term, this will be 12xy squared over 2, or 6xy squared, minus 6x squared y turns into 6x squared y squared over 2, or minus 3x squared y squared. And minus 12xy squared would become 12xy cubed over 3, which would be minus 4xy cubed. And this will get evaluated at y equals 0 and 1 minus x over 2. The 0 once more cancels out, so we don't need to worry about that. 1 minus x over 2. A little bit of a mess, but not too bad. 1 minus x over 2 squared minus 3x squared times 1 minus x over 2 squared minus 4 times x, 4x, what's the best way to write this? 1 minus x over 2 cubed. Yeah, I think we do just have to expand this out, which is kind of annoying, but okay. 1 minus x over 2 squared shows up here and here. So I'm going to do two things at once. I'm going to expand, but I'm also going to factor out this term and this term. So I'm going to expand these, but also factor those, kill two birds with one stone. So on the outside, I'll have 6x minus 3x squared. And on the inside, I'm going to have the expanded version of 1 minus x over 2 squared. That'll be 1 minus x over 2 minus x over 2 is x. And then it'll be plus x squared over 4. Minus 4x times, and okay, I know this seems like we're really grasping at straws here, but let's use Pascal's triangle to expand this. 1, 3, 3, 1. So 1 minus x over 2 squared is going to give us 1, to the third power rather, 1 cubed times negative x over 2 to the 0 power plus 1 squared times negative x over 2 to the second power, and that is multiplied by 3. So we've done this term and this term, plus 1 to the first power times negative x over 2 cubed. Oh, I skipped a power. Hang on a second. Don't pay any attention to me. plus 1 squared times negative x over 2 to the first power. Has to be to the first power. And then that times 3. Now we have done through the second term, plus 1 to the first power times negative x over 2 to the second, and that times 3. Now we've gone through here, and then plus 1 to the 0 times negative x over 2 to the third power times 1. So what does this give us? Give myself a little bit room to write it. Term for term, it's going to give me 1. That's that one taken care of. Switch colors. 1, which is that, plus x minus 2, or negative x over 2 to the first power is negative x over 2, times 3 is minus 3x over 2. The 1 squared makes no difference. And then plus 3x squared over 4. That's that. And then minus x cubed over 8. So that's what goes on the inside here. This will be 4x times 1 minus 3x over 2 plus 3x squared over 4 minus x cubed over 8. And yeah, sorry, we're going to do just one more step of expansion, and then we'll collect all the like terms. So 6x times 1 is 6x. 6x times negative x is negative 6x squared. And then 6x times that is, let's see, 6 and 4 cancel to 3 and 2. So that would be plus 3x cubed over 2. So all of those have been done now. Minus 3x squared plus 3x to the third and minus 3x to the fourth over 4. Those are done. Nope, didn't want to erase that parenthesis. Okay, so now we handle all of these. Minus 4x plus 4 and 2 simplify down to a 2 on the top. So there'll be plus 6x squared, because it is x times x, minus 4 and 4 cancel. And we have x times 3x squared for minus 3x to the third. 4 and 8 cancel down to have a 2 on the bottom, and it will be minus x to the fourth over 2. One more step where we'll collect like terms. So we've got 6x here and minus 4x here. Those are like terms, so that ends up being 2x, and those are taken care of. Minus 6x squared minus 3x squared plus 6x squared. That's going to end up being negative 6 minus 3 is negative 9, plus 6 is negative 3, negative 3x squared, and those are taken care of. Now for the cubes, plus 3 halves cubed plus 3, that's cubed. Make sure that I'm crossing them out. And there's one more cube. That's this one over here. Well, 3 minus 3 is 0. So in fact, these two go away. And the result for the cubes is 3x cubed over 2. The only thing left is the fourth powers. So that'll be this and this. Negative 3/4 minus a half. Negative 3/4 minus 2/4. That's a half. That'll be minus 5x to the fourth over 2. Finally, the outer is going to be integral from 0 to 2 of this. And that's going to be 2x squared over 2, or simply x squared, minus 3x cubed over 3, or simply x cubed, plus 3x to the fourth over 4 over 2. That'll be 3x to the fourth over 8. And then minus 5x to the fifth over 5. That's simply x to the fifth. So this will be x to the fifth over 2. And you can verify that if you take the derivative of that, you will get that back. And this whole thing is evaluated from 0 to 2. The 0 goes away, thank goodness. And our result finally is 4 minus 8 plus 3 times 2 to the 4th power is 16. That's over 8 minus 2 to the 5th power is 32, but 32 divided by 2 is, of course, 16. 16 and 8 cancel down to a 2, and it's all whole numbers, which is very nice. 4 minus 8 plus 3 times 2 is 6, minus 16. 4 minus 8 is negative 4, plus 6 is 2. 2 minus 16 is negative 14. This would probably be classified as like a medium difficulty problem.